Okay, it's all yours. Thanks.
Yeah, so the textbooks are all you need. Actually are for 515, 1.5, 5.2, and recently released from Microsoft. Key idea of this series is it try to break the existing scaling laws uh, by providing more high quality data for the training. So the key idea is use a high quality, meaning have the high education value, textbook style data to train the model, and you can also synthetically generate this textbook data with an existing LLM. And in this paper, at least for 1.5, they use GPT 3.5. And then you can train a smaller model. And the conclusion they want to make is we can achieve comparable or even better performance comparing to, say, Llama, Llama 70 billion models or the Vicuna 13 billion models. So it's a small language model with big ambition. Can we achieve ChatGPT's levels of capability at only 1 billion parameter scale? So that's the vision of it. From 5.1 model, again, it's a very simple, just a decoder-only transformer model with 1.3 billion parameters. The first model is trained with a selection of textbooks quality data. And first they filter, and I think this first model is mainly targeting coding. So all the data set they collected is for coding. First, they have a filtered code language data. It's a subset of the Stack Overflow dataset, and they train a model to filter as the filter to automatically pass out the high education value dataset. So they use the GPT-4 as an annotator, kind of like, just tell me the education value for student whose goal is to learn the basic coding concepts from such a code segment. And then using the GPT-4's labels, they train a random forest classifier based on the code gen embeddings of that code segment. And then they use this classifier to pass out the code segments from the Stack Overflow that have high education value. And then they also have a synthetic textbook dataset consisting of just smaller than 1 billion tokens using GPT 3.5. They also have a small synthetic exercise data of Python exercise and solutions. So this is an example of what they show. What does it mean for high education value? It's like it's very well formatted with a clear descriptions of the functions. Well, this is like a low education value. Well, it's like a very verbose long functions uh, that we should not teach the machine to write this way, right? So basically, they claim that their filtering methods boost the model performance significantly, even without the synthetic data. So that's for the 5.1 model. So for if you train a 350 million parameter model based on the unfiltered, so the originally the big pre-training data set, the coding performance evaluation saturates at 12%. Well, if you train the model, same size model, on the filtered subset, it achieves a much higher performance on the evaluation set with a much, basically, and also converge faster, right? And they can even improve this to 20% by using the synthetic textbook datasets. So this is a synthetic textbook dataset. It asks the model, basically the GPT 3.5 model, to provide a high quality source of natural language heavy text as a description. So if you think of it as a textbook, you kind of actually teaching that person, right? You do not just throw away lots of materials and nonsense to it. You teach, you have the language descriptions to help understand, and then you also show small examples. So basically, this is the kind of like a Python textbook that they use the GPT 3.5 to generate. And then they combine the subset of the filtered the Stackflow dataset with the synthetic textbook datasets to train their phi-1 model. And it turns out that the phi-1 actually is, you see, just like 1.3 billion. It's already getting a boost in the evaluation for the human evaluate coding benchmark, like a pass at one shot, and also another coding benchmark. But like GPT-4 still has the, of course, like the kind of the ceiling for coding is like a GPT-4 still have a very high performance. But like if you compare like this 1 billion parameters comparing to all the other like 500 billion or even or even like a GPT-3 for zero point 0.5, which is instruction fine-tuned, while phi-1 is not a kind of does not undergo the alignment fine tuning. It can get really a boost of performance just by providing a high quality training inputs. So that's phi-1. And then so this is they evolve it to phi 1.5 1.5. Basically they want to test out is whether like we can first they extend the use case from coding to more natural language task, like in various topics they want to see whether the performance can still hold in addition to coding. So this is they and then they also test the idea of whether a synthetic dataset is sufficient. They're trying to minimize, basically they have compared several benchmarks, just removing all the actual collected crawled real data sets from the training, and then they just use the synthetic data and just to see the performance. I think it's a very interesting comparison there. And then this is basically they just show that the phi 1.5 and 1.5 web. So web, it means that it has actually included the real web data, while phi 1.5 is mainly synthetic data set. And both of them is like 1.3 billion. And comparing to the bigger model, of course, like the training and inference efforts will greatly reduced. And also this is how many training tokens are seen. So Nama is like trained on 1 trillion tokens, and Phi 1.5 and WAP is on 150 billion tokens only. So this is the overall of the 1.5 training data sets. Yeah, so this series is all about the training data sets. So they still use the Phi-1's training data. So it's mainly the cold training data. So it's about 7 billion. And then they newly create a synthetic textbook style data set. And to do this, they select 20K topics from the web data to as a seed for this new synthetic data, and ask the ChatGPT model to kind of a GPT 3.5 model to synthetically generate the textbook style descriptions of these topics. And then they use, basically they're trying to keep it diverse, right? And use samples from the web data sets. The only non-synthetic part, so this is overall comment in the training datasets for Phi 1.5 is from the Phi 1 training dataset, which has some direct filtered code segments from the Stack Overflow. And then they also have a filtered web dataset, and this dataset is enlarged to include various kinds of NLP topics, right, like science, math, etc. And again, they get 88 billion tokens is from the Falcon web dataset, and then they have 7 billion tokens from the Stack Overflow dataset. So this is all called like a filtered web dataset. I don't think they have closed any details about what specific prompts they have used to create this synthetic dataset. But if you do some search over the internet, you kind of know, kind of like the idea or framework there, right? So basically, you still need to from the original raw web dataset, you need to cluster them and identify specific topics. and then you can connect all those information as the context, and then you give this prompt, right? So you can ask the LM to give you an outline first, say, and then it will give you outline. And then for each specific session, you can give, say, let's start write the first chapter introduction, right? So and such, right? So the outline can be automatically generated by LM, and then you can still iterate each section and give specific instructions to the LM to generate the textbooks for each chapter. And of course, you can for the same topic, you can also write it for different audience, like for young children, for researchers, professionals, or high school students. So basically Phi 1.5 is trained on, so 20% of the Phi 1.5 is from the Phi 1 training datasets, and 80% is from synthetic datasets. So Phi 1.5, you can think of it as mostly almost 90% is from synthetic datasets. And why Phi 1.5 web only is no synthetic datasets. So it's like they just use the filtered web dataset. And Phi 1.5 web is trained on a mixture of both, right? So it's like 20% from Phi 1 training, 40% from filter web, and 40% from synthetic textbook dataset. And also, none of this model has undergone alignment fine-tuning or extraction fine-tuning. So it doesn't have any like a targeted human preference of the generation output. And this is the results across different NLP benchmarks, like the first on the common sense reasoning. So this is like a 1.3 billion model comparing to Vicuna. I think here is mainly Vicuna and Falcon model. Falcon model use the original like a large website dataset, while Phi 1.5, for example, 1.5 web only use a subset of the Falcon original web dataset, right? So it means that the quality is higher comparing to this Falcon model, and you see that the performance like if you comparing to the same size, like 1.3 billion model for Falcon, with a smaller pre-training data set, actually the performance improves, right? There, although some task is still pretty much the same, I think it improves mode for this ARC challenge dataset. And if it combined with synthetic, like textbook style datasets, which is the Phi 1.5 web, so it contains both the real and synthetic dataset, you get a direct, very high boost of the performance over here, and it even beats the Vicuna 13 billion. And then 1.5 is only the synthetic dataset. So if you only use the synthetic datasets, you already have can beat the Vicuna 13 billion over here. And I would say like adding the web dataset right now over here is like only add a very incremental gain over just using the synthetic dataset. And also like the language understanding, I think maybe this is more challenging. So larger models may help more here, especially for this data sets. So you see like there's still a clear gap over here for Phi 1.5. But if you kind of compare like, but I think the trend still holds over here, except for these two, mainly. And like using a subset, I think is still maybe I think the reason for this is I don't think they covered all the topics of the original web dataset, and they also mentioned that the next step is to expand the topics in their like in their, I don't think it's the web only, like in their synthetic dataset to see like whether it can bridge the gap over there. And then the multi-step reasoning is like elementary math and coding. Yeah, so the performance, they also add the performance from Llama 65 billion. So for the math, there seems a still advantage there using a larger model. But for coding, it seems the Phi model is really winning in the coding area. Maybe that their coding filtering classifier really boosts the performance over here. Yeah. And also they saying that here, for example, the web data, like so this is a synthetic only, and this is with the web data. And with the web data, it actually helps more for the multi-step reasonings. So it's still very case by case. Like previously, we see that adding web data, real data doesn't help much. But here, like for example, for the coding and this math, especially coding, the gain is a lot with the actually with both synthetic and web real data set. Actually, they have also released the Phi 2. I think it's end of last year, and also the CEO of Microsoft basically also they he mentioned that they launched the Phi 2 model, and it's very surprising power of small language models at the Ignite conference. So Phi 2 is trained on a lot more tokens comparing to Phi 1.5. Um, yeah, so and it's again like the key idea is on a mixture of synthetic filtered and also like a high education value web data sets for both NLP tasks and coding, and like seeing the model scene is trained on much more tokens, and then they did see a lot of improvement comparing to Phi 1.5 model. The next slide is also very interesting. They compare the performance to Llama 2 and Mistral here. I believe Mistral has larger ones, but at least comparing to like 2.37 billion comparing to 7 billion, the performance actually, uh, yeah, uh, actually like improves a lot, especially for math and coding task. They also compare their performance on Gemini benchmarks. Yeah, so they claim that like at a similar with a similar size on Gemini, they can also boost the performance with a higher quality training data set. So the key takeaways from this is, this actually is a original sentence from their paper, is creation of synthetic data sets will become an important technical skill and a central topic of research in AI. So yeah, basically it's kind of like we have a really huge LLM. It's kind of like a data distillation for a smaller model, right? And how can we effectively create a synthetic data to train a smaller model that can have comparable performance to the really huge model. And also the results challenge that the capabilities of LLM is not determined, is not only determined by the scale, and data quality should play an even more important role than previously thought. Yeah, and their results benchmarks indicates the feasibilities of achieving high-level capabilities with smaller LLMs. And also it may show a direction for more efficient and environmentally friendly AI systems. And then they also point out the future direction is to expand. Basically, I think they invest a lot into how to systematically create more effective synthetic data sets to train such a smaller model. And also to expand it to cover a broader array of topics. Since they have not done any human preference alignment or instruction fine tune yet. So, but they do want to see what is the additional lift they can get for more specific task.